Qual è quello che va nel micro? Qual è l'input? Aspetta, sentiamo.
Ok, questo qua.
No, questo è quale?
Questo qua.
Ah, ok.
Da qua quindi volevo seguire questo qua.
Questo è l'input, giusto? Giusto? Sì. Questo piccolo?
Sì.
È l'input. No, just a second. No. Pull it down.
Yeah. So let's start with good morning. We don't have a bunch on the MBONE side, but I do want to leave time for PIM. And this is a little light. I mean, some people I was expecting to see, I don't see here, but then again, I don't know if I've even seen them this week, so maybe they're not here. But before we get started, confirm you're in the right place. This is both MBONED and PIM. We're going to run the groups concurrent. We have a lot of overlap in participation and content, and just for the sake of density, we've got in the IETF and fighting for space and time. We thought this would be a good idea. Now, we've done them back to back in the past. I think this is the first time we're running concurrent here. So you're not seeing things. This is what's supposed to be up here right now today. And before we get started, then, we have to begin with a minute taker. This is always the hardest part to get someone to do. I've got no bribes up here other than accolades at the list and lots of thank yous in the room. But we'd like to have someone who's going to stick for both, take the minutes for both, just separate them in kind, and we will split and submit. So who's willing to help us out here? This is all part of your participation requirements. If I don't see hands, we're going to assign, and that's never fun. I love when people immediately look down, they're reading their email as soon as I ask for help, right? No one wants to admit they're actually paying attention. Don't feel guilty, Joel. You don't have to. You're the boss man right now. Anyone? Minutes? How do you do this? How do you threaten people?
It's hard.
Mm-hmm.
Yeah.
Will it take minutes? I see eye contact. That's usually a rough sign on your own, right? Nobody else is looking up here. Can you do it? You just, when people come to the mic and ask questions, you log their name and what their question is, and you keep minutes of the dialogue. So you're just typing as you go as best you can. When complete, send it to the chairs at MBONE and or chairs at PIM. And no laptop.
No laptop.
Wow, that's why you're all proud standing up and giving me eye contact, because you have no, well done. All right. Okay. No opportunity. All right. Well, appreciate you being here, and next time we'll catch you. All right, your turn. Attack someone. I'm not going to go after your person you're presenting, right?
I do it, but I have to come.
Yeah. If you're willing, that'd be great. But I've stuck you before, right? I'd like other people to step up and participate. If we get down, that entire table is not paying attention.
Yeah.
I feel like a grade school teacher.
Yeah.
Who wants a star next to their name? The laptop, I was just taking for walking late. All right, show of hands. Who has never taken minutes before? Show of hands, who has taken minutes before? Oh, all right, we got some honest people here. I love that. Thank you, Joel.
Yeah, thanks. That's great.
Yeah, let the note show that the AD had to step up and do this. Okay, we got people still rolling in. This is MBONED and it's PIM together. So come on in, we're gonna run them concurrent. Actually, we'll be talking at the same time. No, we're gonna run them sequentially here. So begin with note well. Well noted. Everybody's on board, nod, hum. Great. All right, the agenda. We have 3 items right now for MBONED. Anything missing here? You guys take a look at this. Did I miss a submission? There's an omission to mention, nothing? Nods, looks good. Anyone awake? All right, we got a nod, there we go, excellent. All right, let's start with the multicast service model, Yang. So, Zhang, you in the room? Oh, excellent, all right, come on up.
Good morning, everyone. I'm Sandy Zhang from ZTE. It's my presentation for multicast service Yang. Next, please. There is many existing multicast Yang models, such as PIM, IGMP, BEER, and so on. And these models describe different aspects of multicast. The models are decentralized and they can't describe the global multicast service. The Yang of PIM, IGMP, and BEER all focus on the protocol itself. So we think maybe we use a new model to gather these models to describe multicast service. And to the deployer, maybe some items in this device model, they are not concerned. So the global general service model is lacking. Next, please. What's the multicast service model? The model is a general and all-round multicast service model, and it will guide the deployment of multicast service. And this model will focus on the outline of multicast service. And the model will assist with the existing multicast device models to implement multicast service. Next, please. If you are familiar with BEER technology, you will be familiar with these levels. Multicast service can be divided to 3 levels: overlay, transport, and underlay. Next, please. So we define the Yang model from the 3 levels. We define the overlay technology, transport technology, and underlay technology. Next. Let's see the detail of overlay. The overlay includes basic multicast flow information, egress nodes information, and the possible overlay technology. And we will see when we want to define a multicast service, we may use the source address, group address, and we know in overlay, we will use the ingress nodes and egress nodes to describe the flow in the flow's direction. And when we use BEER for transportation, we may use the BFR ID to describe the nodes. And the MLD, MBONED is the overlay technology existed for the multicast information delivery. Next, please. Let's see the detail of transport layer. You can see BEER and MPLS and PIM is all the potential transport technology for multicast flows. All the technologies that can be used to carry master flow, all defined here. The characters of technology that the deploy constants will describe here. And this part can be associated with the young models of protocols such as BEER, MPLS, PIM, and so on. We will see if we use BEER to transport the multicast flow, we may define which subdomain we will use and the potential encapsulation type, and we will use which bit string length or set identifier, and some feature we will use for this, such as ECMP, FRR, and so on. And we will use MPLS tunnel for transport. We will define the MLDP associated information or the P2M-PTE associated information for it. So PIM is a traditional transport layer. So we define the PIM feature for it here, such as graceful restart and BFD. Next, please. Let's see the underlayer. This layer is simpler than the other two layers because the BGP or OSPF, ECS or PIM, it's these models is describe the protocol very gently. So we will only point out which protocol we will use for underlay technology. Next, please. Let's see an example. If we want to deploy our IPTV service, at first we know the basic multicast information, such as source address and group address. We define it here. And we want to use BEER to transport this transport technology for this. So we define, we may use subdomain 10 for this transport. And we define the possible ingress node and egress nodes. But we think we may auto discovery for some source and receivers. So we define the MLD as the overlay technology. And we use BEER for transport technology. So we may define the bit string length, and we want to use ECMP here. And the underlay, we may use OSPF for this service. So we can imagine that when we want to deploy this service, we put out our telephone and we click the service app, we input these parameters and submit. The other things is done by controller. And the controller will, according to this, generate the device models corresponding, and the service will be deployed successfully. That's all. Any comments?
This is Stig. I have one question about the transport. So for a single M route like an S-G, there can be multiple transports, right? You can have people have joined the same route on like using different transports. So do you support having multiple transports for the same S-G?
We may define several technologies for the same service. So we can change the model to suit it. Yes, we can use different transport technology for one service.
Okay.
Or for the same M route.
Yeah, this is Percy. In general, the concept of deploying a Yang model is fine. No real concern about that, but I just wish to ask, since this is a general Yang model that you're trying to develop, solely for multicast, whether it's BEER, PIM, or SSM, whatever, are there other general Yang models that you could use and maybe modify, or is this something that you wish to create specifically just for multicast use? Thank you.
The other model, I think, not specifically for multicast. We will see maybe in L3SM there is some MVPN relative information in it, but it's not for multicast itself. So it's this general model, I think it's not another one. This is the first one.
Shifeng Liu from Ericsson. Actually, the L3SM service model, they do include the multicast portion. So they ask us to give comments. So probably you want to check with them.
Sorry?
The L3 service model, they do include the multicast portion. They're trying to put them in together.
This model will assist with the other protocol model together.
So what's the relationship between this model and the layer 3 service SSM model?
This model is how to say? It's a general site. Just we use a general site to see the service, and we think we may use some technology such as PIM or IGMP in this service. So we only point out that the technology that we will use for this service. So this is a you can see it's a global. Yeah. When we want to deploy a service, at first we deploy the general, and we point out that the especially young model we will use for it. This is we will reference the especially young model of protocol in this.
This is Stig again. So I think it's useful to have a service model, but I don't know enough about how service models usually are designed, and it would be useful to have operators or users to say what do they expect from a service model.
Yes, we at first we think this site may be a service site, but in another hand, we think if we change my point of view, we may see this model is focused on the data plane. We can see the source address, group address. It's data planes. It's all the data plane information. So I think the name of service model is temporarily sort of me. So I think maybe there is another name for it is more suitable. So I think that I use service young temporarily. That's but I think maybe another more good name for it. I think this model is needed for multicast.
And some background about the service model. The layer 3 service model is defined currently by a few service providers. They don't want the vendors to define their service model. So what they do is that they use that model not on the device. They put that on the service architecture and then trying to transform from user perspective into the device model. So I don't know if your service model is doing the same thing or not. But it seems like there's some relationship between this one and the service model. So probably.
I think to deploy, I know that several device service model is defined by the deployer, but I think he may use device model to deploy the service directly. But I think some detail of the protocol, young model, they will not concern, such as beer technology. We know BFRID is an important character of the technology. But if we want to deploy a service, we define every node's BFRID in it. We think it's more
so this
complex.
is a device model actually?
Yes,
okay,
yes,
okay,
yes.
okay. So that's the confusion come from. So probably, I'm not sure, probably we want to change the name or something. So because the service model in that sense, it's not device model. So if you look at the YAM model category, they separate the service model with the device model. So you don't want to name a device model at the multicast service or something.
Maybe can change the name, multicast model. You can give me your suggestion for it.
Questions?
Thank you. Thank you.
So if I just may ask a completely ignorant question, there's two things to evaluate here from what I understand. The one that's right in our face is, are these the proper elements and structure within a Yang architecture to define the flow? The other is, how does this fit into the overall design intent of Yang and the modeling across the internet architecture as a whole? That's the part that I seem to be missing. And without that, it's hard for me to really look at this and see if those right elements are defined in a way that is useful. So again, that's just my point of ignorance. So let's step deep. We have a Yang doctor assigned to this to make sure the structure within the doc is accurate. And do they understand how this fits in the overall? I guess we need some sort of navigation doc to understand how, or someone can point me to it, understand how the Yang architecture is supposed to look and how these pieces fit in. And then we can understand how that goes. I mean, just like I said, it's my ignorant question to understand how it fits, but am I alone? Does everyone have their head around this stuff and I'm just standing by myself naked in the woods? Okay, Percy's on board, all right. And that's as an operator too, which I think would be some important feedback.
So, Stig again. So this in a PIM working group, we have a design team that has been working on multicast models for Yang, or Yang models for PIM and IGMP and so on. So maybe it would be nice if some of them could have a look at this draft maybe and see if it looks reasonable.
And I hope they're in the room.
At least one of them is here, I see.
Thank you. All right. Next is Percy. Did it.
Okay.
All right.
Okay. All right. We are talking here about the best current practice on multicast across interdomain peering points. Next slide, please. We started last call on the first version of the draft sometime fourth quarter of last year. In Yokohama, we gave a presentation on the resolution of the comments. First set of comments was from Dale Gardner. There was one general comment, 6 specific comments, and we agreed on the following changes. Section 1, Section 3.1, Section 5, Section 6. Again, this was all discussed in Yokohama. We accepted these changes. Next slide, please. Next set of comments were from Lenny. There were 2 general comments, 2 specific comments. We felt we gave our responses in general. There was disagreement. the two sets of comments. One was on whether the back office functions were necessary. I think we went into a fairly long discussion as to why we felt it was necessary. We gave some comparisons on how we are doing the job here versus how the CDNI folks were doing. And we felt we gave our response. Lenny, of course, was not there, so it was difficult to know exactly whether he accepted it or not. Anyway, we came away from the meeting thinking that it was all good. Next slide, please. We put Dale's changes in. We uploaded version 1 of the draft on January 21st on the email list, and we requested last call for that one. We got feedback again. Lenny came back and said, look, all of my comments have not been resolved. They should have been posted on the email folder. He did agree that as far as on the back office functions, he has his view, we have ours. Let's agree to disagree, which was good. And then he did say there are other comments that we still need feedback from. There was another gentleman, Tim Chow, who also provided some comments. So here goes. Next slide. For Lenny's remaining comments, the section 1, he asked us to focus on the use of SSM as the protocol. He provided some draft text for that purpose, and we agreed to incorporate that into the next version of the document. His second comment was use cases 3.3, 4, and 5, which all involve the use of the AMT tunnel. That may not be necessary, and he did make us this offer. Again, we may agree to disagree on that. So on the email list, next slide, please. We gave our explanation, our pushback. The assumption's always been that the first administrative domain is a native multicast, and that there is a peering point. It's previously established, it exists between 81 and 82. Beyond that, that gives us 5 possible use cases. The first one's fairly simple. If 82 is multicast and native multicast, and if the peering point is also native multicast, then we don't have a problem. It's end-to-end native multicast. If, however, the peering point is not native multicast, then we come up with use cases 2 and 3. In the use case 2, we just set up a GRE tunnel between the two, and off we go. Use case 3, instead of a GRE tunnel, we establish an AMT tunnel across the peering point. Again, these 2 tunnels would be dedicated solely for multicast, and that's how we got use case 2, use case 3. And just when we come to the meeting.
We just came back. All right.
Okay. Yeah. All right. Next slide.
Thanks.
Okay. So if, however, 82 is not native multicast and the peering point is not multicast, then we have use case 4, use case 5. In use case 4, you start out by establishing an AMT tunnel from the relay in 81, and you got a series of long tunnels all in series going through the peering point all the way across 82. This may not be very efficient if there's many users. If there's thousands of users, you may have a problem that way. Which brings us to use case 5. In order to alleviate that bandwidth inefficiencies, we create a concatenated set of AMT tunnels. There's one tunnel across the peering point. There's some other tunnels that you established in general, and then the end users can only establish their own AMT tunnels on the network edges. So that was our pushback. We decided to add that specific assumption to section 1. Administrative domain 1 is enabled with native multicast, and there is an existing peering point between 81 and 82. And then we decided to take up Lenny's offer. We do agree to disagree. The main point is, in our network, we have all 5 configurations present. The configurations depend on the circumstances, who we are establishing the agreement with. It all depends on us, our partner, the physical aspects. So that's basically our situation. With that, next slide. The suggestion, Tim Chow came up with some comments. He did support Lenny's text change on the SSM use, and he was generally supportive of the rest of the BCP. So there was really no major resolution necessary. Next slide. So we created draft version 2. We put in the SSM protocol change per Lenny's text. We added the assumption that we described in slide 7. We did some cleanup, some edits. We uploaded version 2 on March 21st. And here we are back again requesting last fall. Any questions?
Can I get a show of hands who here has read the draft? Wow, that's rough. So what we're asking here is potentially going to last call on this doc, but without anyone in the room having read it besides myself and Percy, I'm assuming here, it's hard to get a sense of the room support. Lenny's read it as well. Yes, Lenny's read it well, and we've had numerous calls about it, but Tim is not here for some reason.
By the way, so yeah, this is Stig. So I've read our previous version of the draft, but I haven't read this one, unfortunately. But with the SSM changes, did you still talk about ASM also, right? You didn't
We
remove
do,
that.
but the recommendation was, look, let's focus on, if you want to do this, use SSM. And again, we took Lenny's text.
Okay,
And that's what we
yeah.
did.
But I'm happy that ASM is still there. So.
Yeah.
Okay.
That was the other problem. There were some competing views.
Yeah.
So we did keep the language, but the recommendation for Lenny's text.
Yeah. No, SSM is great, but not everyone uses SSM.
That's
so,
right.
yeah.
So I will take it to the list and hope there's more people engaged who have read it then. I'm going to, again, play my kindergarten teacher role and beg people to get on board if you're going to participate. Participation means at all levels, at least reading and providing feedback. So I'll look for this. Thank you very much, Percy. We'll definitely take it to the list.
Yeah, I'll read it and myself at least. Yeah.
Did Torles have any comments?
You know, that's why I say I don't see Tim here. I know he's here this week. I was with him out last night.
Okay.
Torles I've seen here this week, but he may have another group conflict. I'm not certain.
Okay. All right, thank you.
But those are good points. Those are the usual suspects that we should get on board, get some feedback. Thanks. All right. We have one more in the MOD agenda. Perkins. Excellent. All right, watch me jump through these hoops, though.
I guess they're in other working groups. It's kind of
Yeah, interesting. We may have had some conflicts here, right? Which is the case. I'm figuring this out. I like that they're all online.
Well, good morning. I'm Charles Perkins, and I'm making this presentation here, essentially a repeat from the presentation I made in Interior yesterday. So this is a discussion about problems that are noticed when trying to run multicast protocols over wireless media. And this is actually an outgrowth of a presentation from Interior in November made by Dan Harkins from material developed in 802.11 working group. Dorothy Stanley did a lot of that. So that was fairly, there was a lot of interest in that presentation, and subsequently we decided to make an internet draft out of it. And so here the internet draft has been submitted, and so this is a presentation about that draft. Next slide, please. So there's some things about wireless media that is going to affect any multicast solution, and this is a brief description of some of those things. So that if you have a group of wireless devices and a multicast sender, then in order for them to all receive it, you have to send it at high enough power so that all of the, even the most distant device can receive that. So that's one consideration, and usually means that you have to send it at the highest power in order to get all of the receivers to get it. And similarly, if you have them, depending on exactly the modulation scheme, but it can well be that you have to transmit at the lowest rates to have all the receivers receive the multicast packet.
Okay.
So
questions along the way. Is this because you're actually sending individual to each one of them MAC addresses, or you actually do
Oh,
multicast?
well, this I think is under the assumption that you're actually using multicast. Okay, right. There's more than one way to implement multicast, which we'll talk about. Roughly speaking, in order to do a transmission that gets to all the receivers, you have to transmit in a way that satisfies the neediest customer. And so that boils down to, that results in having the packet over the air use more of the medium. In other words, if you're transmitting at a lower data rate, then you're interfering for a longer time. And if you're transmitting at a higher power, then you're interfering over a larger area. So these are combined to produce unwanted effects. In addition to the problem with the media occupancy, it turns out that generally speaking, unicast is more reliable than multicast because, especially over 82.11, you might say that it's well designed for unicast, and there's an acknowledgement that comes back, and then retransmissions can occur. But for multicast, it's generally not acknowledged, and so it's difficult to know for sure if all the receivers have received the multicast frame. And there have been some pretty high rates of packet loss observed, in excess of 10 or even more than 20%. So this is a serious consideration. Furthermore, the exact range of interference is not very well defined. If you look at the actual, let's say, packet capture region for wireless transmissions in general, it really looks highly irregular, and it can depend upon things like what cars are driving past, or a lot of time varying considerations. And finally, if you have an access point that's redistributing multicast information or sending out multicast to wireless receivers, and it's also tied into a wired LAN, then the multicast operation on the wireless can also easily affect the wired segments of the LAN. Next slide, please. So these are all parts of the discussion from last November, and then the internet draft that's currently out there. First of all, I want to mention that it's not complete. This draft has a lot of segments that should be really need additional text. But something is better than nothing, especially for a -00 draft. So this is the current outline, and some of the parts of the outline are pretty spare right now. But anyway, so first there's a discussion about what's actually going on at the wireless medium, and then we try to identify the ways that matters. Oh, question? Pardon? Oh, so yes, and describe some of the uses for IP version 4 and version 6, and then there's actually has resulted in some deployments disabling multicast, and then there's a section in the draft that talks about what's been done to counteract a spurious neighbor discovery based on results from IETF observations on people trying to scan the networks and get information from that. So then the next part of the draft talks about the kinds of layer 2 optimizations that have been put into place and designed, especially from an IEEE standpoint. And then I'll talk about actually the mitigations that have been put in place for this spurious neighbor discovery problem. Okay, next slide, please. So proxy ARP boils down to being a really good idea for wireless, and so that access point, or AP, is in a very good situation to know the MAC addresses for the wireless stations. STA in 802.11 terminology is the wireless device or the station. So the AP knows the MAC addresses and it can just resolve ARP requests without having to actually put things over the air. Question?
Yeah, this is Dino. Does that mean the access point doesn't forward our broadcast?
Yeah.
So the
November. And I think just fair to say that there was a lot of interest about that. So then Dorothy and JC and me and Dan Harkins, we talked about putting out a presentation, and this is the result of that. Plus, we had included the text from Warren. But last year, I was, let's see, where were we? Last July, I made a presentation to, pardon? Prague. Oh, that was a fabulous IETF. Anyway, so made a presentation there, and there was interest there, but then that draft, the difference with that draft was mainly just problem statement, and this draft incorporates a great deal of solution techniques. So there's a somewhat different approach and motivation, especially motivation from the anterior presentation in November. But it's also the case that I didn't know what was happening with that draft. So basically it just didn't evolve. And then there's another draft from Eric Vinke from Six Man. This is an expired draft, but I recommend you take a look if you're interested in this problem. But this Vinke's draft, Eric's draft, is not really specific to wireless, and certainly not to 802 wireless. By the way, this is intended to be really from the standpoint of IEEE 802 wireless, which if you probably have some familiarity, but 802 wireless carries a huge predominance of the world's wireless data, so it makes a big difference. And finally, I put on here that PIM has a charter item to sort of do some of this work. So that's another good reason that I think that it should be aware in this group. So that's it for my presentation, and I'm happy to take questions or more questions.
This is Dino. Did IEEE consider running a 3-decade-old problem for the retransmission case called LAP-B, or is this new version of retransmissions better? Do you have any comments or opinions about that?
Well, wait a minute. So IEEE wants to run 3-decade-old protocols like Ethernet and stuff, or?
Well, I mean, LAP-B worked pretty well. It was simple. It had somewhat of a window size, so you could actually do some bursting, and it's a link layer reliable protocol. So I'm just wondering.
The IP, you're saying?
No, at the RF level, at the AP level, between BSSs and stations, right?
I don't know how to answer that question.
Dorothy Stanley, Hewlett Packard Enterprise. So just one clarification on a couple of the features that Charlie mentioned. Directed multicast. So directed multicast, as it's defined in .11, in fact requires changes both at the AP and the station. There are many implementations that are vendor specific for doing the same function, which is essentially converting multicast to unicast for delivery to the end devices. And in those vendor specific ones, for example, the Aruba system, or if you buy pretty much any other enterprise vendor system, the decision is on the access point only. So the access point looks at the traffic and the nature of the traffic that's being served to the client devices, and can decide to based on the traffic characteristics to optimize by either sending as multicast or sending as unicast, and it makes that decision unilaterally. And so that's just one of the techniques that enterprise class access point systems use to improve the performance overall. The difference with DMS is it provides a way for the station to actually request the service, which does not exist when the AP makes that decision unilaterally. And just generally, one of the pieces of feedback that we received yesterday was to add information into the draft, that initial int area draft that we're working on, to specify or to describe for each feature whether it is access point specific or requires involvement of both access point and station. Because from a deployment point of view, something that is just required or on the access point is a lot simpler to deploy and to get out there. And as I said, both the proxy ARP capability and the conversion from multicast to unicast based on the traffic characteristics is something that all of the enterprise class devices do today. So we encourage, the discussion yesterday was very productive, and we have a number of additions that we're going to include into the draft. One of the areas that I think will be the foundation of additional work is for neighbor discovery. There are a lot more, there are features coming that are being added to neighbor discovery that may or may not, that may require extensions at the layer 2 level, or at least knowledge at layer 2, when you're adding new capabilities that are intended to go from the end device, or from the network to the end device. So we'll have to look at those. Thank you.
So I'd like to, this is Dino, I'd like to follow up on that comment. So to make the ARP proxy stuff really work effectively and not cause the other stations to wake up if they're powered down, is that the sending station shouldn't send a broadcast. It should really unicast the ARP request to the AP. Because if you send it on this broadcast channel, they may inadvertently wake up. And if they don't, then the stations would have to change to make it work. So how does it actually work, or what's being proposed?
Okay, I think first we have to clarify that traffic, at least in a .11 system, multicast traffic goes from the access point to client devices. Client devices only unicast. So a multicast packet that is sent from a client end device over the air is unicast. It is not multicast.
Wow. All right. Thank you very much. Comments there. So I will hand this over to Pim.
Thanks.
Welcome. You're now in the PIM working group meeting.
All right, welcome to the PIM working group. Thanks. Don't see anyone leaving the room. That's good. You came from MBONED and you're staying for PIM. So this is the note well. You already saw this earlier. So, and this is the agenda we have for PIM today. So yeah, so Mike McBride, he couldn't be here today, so I'm sharing this alone. At least I have Greg here by my side. But, so yeah, I'll go through the working group status, and then there's a couple of drafts that I'm on off-row, so I'll present those, and then there's also 5 other drafts here from various people. So for the working group status, we finally managed to publish 4601 bis. Thanks to all the authors and everyone that contributed. I think before it was like a very easy effort, but it took like 4 years or something like that. But yeah, it's finally published. Then we got the explicit RPF vector draft that's almost done. From what I understand, it actually has been approved, but there's some minor edits that are requested before it actually will go to the RFC editor. Yeah, see Alvaro is here, so let me know if you have any comments. We also have this explicit tracking draft, and there's been some, yeah, so the Alvaro, our AD, he wanted some changes to the document, and there has been some improvements, but I understand there's still some more changes needed to that draft. So yeah, it's kind of going a bit slow, but hopefully we will get there eventually. Then there's the hierarchical joint attributes draft, which is an IETF last call right now. I haven't seen any comments on that yet. And then we got the multiple upstream requirements draft. Yeah, I see Carlos here. So yeah, there's no update for this IETF, but.
Yeah, this is Carlos Bernardo, UCCM. Yes, we did an updated draft for the last IETF. We got some offline comments from a colleague from DT. So we are actually working on these comments, and we plan to do at least one new revision before Berlin and to present it in Berlin. So that's the current plans.
Okay, right, thank you. Yeah. And we also have this joint attributes for Lisp draft that will be presented today, and also the source discovery draft. We have a PIM Yang model draft that will be presented today. And we adopted a DR improvement draft since last IETF. It's not presented this time, but please comment on the mailing list so you don't need to be at meetings to do work. We can also do work on the mailing list and see if we can move forward on that. That's the status I have. And then we can move on to the presentations unless there's any comments. All right. Let's see. So I don't even, let's see, I don't remember my own agenda exactly here, which is first. Okay, yeah, source discovery is first. All right, so I have to kind of act as both chair and also presenter of my own drafts here today. Yeah, this is the source discovery draft that I've been working on together with a few other people. ICE plus also a couple of people that actually want to deploy this solution are involved in working on this draft. So I'll explain a little bit background. It wasn't presented last IETF. So, but basically we're trying to do PIM in, it's sort of a new way of doing PIM in a way. We're trying to do ASM, basically have source discovery, but without using a rendezvous point and without using a shared tree. So the basic idea is you somehow distribute information about sources to lots of routers, and they can join shortest path trees. So all data packets are going on shortest path trees. So what we are proposing in this draft is, first, it's like a generic protocol for distributing information throughout the PIM domain. It's sort of like BSR. It's like RPF-based flooding. So this draft is named like BSR something, but we are not using BSR. We figured it's a little bit too different from that. But we wanted to make this generic protocol just so that if there's other use cases in the future for distributing information, it's easy to just define some new TLVs. But yeah, we make use of this PIM-based flooding to send source announcements. So the basic idea is that a DR would announce directly connected sources. So basically, instead of sending PIM registers, you announce the sources in this new protocol. And by doing this, we avoid rendezvous points. There's no single points of failure. It's pretty good redundancy, and it's pretty simple. You can think of it, if you like, as SSM plus source discovery. But the source discovery is done in the network. And there's quite some interest from some deployments of PIM dense mode, but they would like to use this instead. It has some of the same properties, but it's also simpler than dense mode. And particularly, there is interest from deployments of ad hoc networks where they might have like radio links or where you don't have much bandwidth. You don't want to have any unnecessary forwarding of data packets like you have with dense mode. Also, this solution can coexist with other PIM modes. It's pretty easy to do an implementation, and there is a prototype where you can say that for certain group ranges you use this, for other group ranges you use, say, sparse mode, or regular sparse mode, or BIDIR, or what you like. So I mentioned some of this already. Because there is no single point of failure and no wasted bandwidth for unnecessary forwarding of data packets, it's fairly good for ad hoc networks in particular. Today they're using dense mode, but there's not that many dense mode implementations, and there's various issues with the dense mode spec. And yeah, I don't think people really want to work on improving dense mode. Well, it's basically existing sparse mode, and you just add the source discovery to it. So it's a fairly small change to sparse mode. And the Swedish Army, they have been testing a prototype of this in the field, and they are pretty happy with it. They want to deploy it. And there are smaller ad hoc networks that also are looking into this and say they want to deploy it. I also think it could be a good fit for things like IPTV. If you have like high rate streaming, you don't want to unnecessarily send HDTV or whatever, do like PIM registers and forward that on shared trees. So it's better to just use shortest path trees. And if you only have, say, a few hundred sources, then it's not a problem with the scale. The main issue with this solution, honestly, is that you are sending source announcements everywhere in your domain. But if you only have a few hundred sources, I don't see any problem with that. If you have thousands of sources, then this might not be the best solution.
Quick question to that comment, Zdeno. Did you consider advertising, instead of advertising the specific sources, maybe subnets or some prefixes? Then you could reduce the amount of state, right? Especially if the sources are co-located, then you could do subnet comma G far away. Right?
Okay, that's a good idea. Yeah, thanks. And yeah, so there is a prototype of this. There's people interested in deploying it. And it seems fairly complete from the offer's perspective. We need your help to improve it further. So thanks for that comment. As an offer, I think it might be ready for last call, but we could really need more people to review this. I'm sure there are things we haven't thought of and improvements that can be made. And Dino made one good comment here. So I'm really hoping for people that can help review this. I don't know, how many people have read this draft already? Okay, that's great. It's like 3 people at least. Okay, thanks. Yeah, it would be really great if those that are interested, a few of you could have a look at this and give me comments on the mailing list or so on, but before the next IETF meeting. We have a problem in general in this working group where we don't get enough review of documents. So,
this is Dino. Another comment. Did you consider? I think it's better doing it as a separate protocol or in PIM. But did you consider maybe modifying the IGP so it can identify the subnets that it's already advertising as multicast capable? Or I mean, there's a disadvantage because as sources come and go, then link state advertisements have to be flooded. But there's a natural way of doing that already, and there's reliability and checksumming, and all that protocol machinery is already built into ISDIS and OSPF.
Yeah. Oh, I have been thinking about that. It's certainly a potential way of implementing this. So yeah, I was partly thinking of writing this so that you can kind of separate which protocol you use for the discovery from sort of the overall mechanism. That's something that could be done. But yeah, I would say from PIM perspective, it's really easy to implement this. All you need is some way to learn about the sources, and this is just one of several ways you could do that. Okay, thanks. Okay, then I'll move on to the next presentation.
One other comment, this is Dino. You do have a mapping database that you could advertise sources into as well, so you don't have to flood them. So there is a mapping database available where you can actually, when the sources are discovered, when they start sending at the edges, you could put them in a mapping database, and then the receivers could check the mapping database. Then the intermediate nodes don't have to keep the state or flood, and they only keep multicast tree state when it's joined, where it's joined, right?
Yeah, I'm trying to avoid having a single point of failure or...
Oh, no, the mapping database is like DNS. It's not a single point of failure.
Ah, okay. Thanks. By the way, yeah, I should add though, with this flooding, if you have a router that you know is not going to be like a last stop router, you can choose to just forward the messages instead of storing the state. All right, then I'll continue with the PIM join attributes for Lisp. So this has been a working group draft for a while, but we've basically been waiting for the Lisp working group to progress before we were allowed to move ahead with this draft. So there is RC 6831 for how to do Lisp multicast. And it basically relies on sending PIM unicast joins between Lisp routers. And that sort of works, but when I was working on implementing this and realized that we need some more information than what is usually passed in a PIM join. So the idea was to use, is to use join attributes to pass that extra information. And basically, we need to know some source RLOC from the Lisp router sending the join, so that we can do solicit map requests in case an EID moving like mobility, and also for doing explicit tracking. Also, there's implementations doing head-end replication, so unicast transport, and in that case, you also need to, we need to know where to send the unicast packets. And we also basically want to have a way of signaling so the receiver can say whether it wants unicast or multicast encapsulation. So this has been implemented, and okay, yeah, let's see. So maybe this helps a little bit. So here you have like a typical Lisp deployment. You have like 4 Lisp sites, and you have like border routers called either ITRs or ETRs, like ingress tunnel router or egress tunnel router. And between these, so like in this case, we have like receivers at the bottom here. Some say like R11 might send a PIM join to S2, for instance. And inside that join, we want to say whether we want unicast or multicast, and also what our source RLOC is. And let's see. Okay, I think I'll just skip this part. But the idea is pretty simple. These red line arrows here are the unicast joins. So this was presented in the Lisp working group a few years ago, and they thought this was useful. We agreed that it was best to adopt this in PIM because we're defining these join attributes, and we need to make sure that they are formatted correctly and stuff like that. There are multiple implementations, but we need to get this published so I can get IN assignments out for the join attributes. So we need to decide on the next steps. It's a very simple draft. There isn't really much more to do with it, but it could be nice to get some reviewers. And also, maybe it should be reviewed and maybe a working group last call in the Lisp working group. So I wonder if our AD has any thoughts on whether we should take this to Lisp or to proceed with that.
Hi, Alvaro Rosana, AD. Sure, if you're going to get last call in here, I think you just copy Lisp and let them know that you're last calling it. I don't think you need to last call it there as well.
Okay, so yeah, so we don't need like a formal last call, or just make sure that they're, they know about the last call here and they can comment if they have.
Yeah, I think that's enough.
Yeah. Okay, great, thanks.
This is Dino. I just let people know that I'll be giving a presentation to Lisp Working Group on a use case of using that machinery.
Yeah, so Dino is working on a better way of doing this, which is basically using the list mapping system instead of these unicast joins. Okay, so let's see. How many think this is ready for last call? I don't know if you actually read this document, but if you read it and you think it's ready for last call, can you raise your hand? Okay, it's a couple of people. Okay, thanks. Anyone think that this is not ready for last call yet? Okay, I'll talk, since it's my draft, I'll talk to my co-chair. I'll talk to Mike, and also probably take this to the mailing list to see that we have support for that there's no objections to go to last call. Okay, thanks. So then I think I'm done with all my presentations here. Let someone else speak for a while. So the next draft is the PIM-Young model. Let's see. Oh, that won't work, I guess, but I'll do it.
Hi, I'm Xifeng Liu from Maxim, reporting the status of the PIM model on behalf of the design teams and authors. Okay. This model has been working by the design teams, and we're still discussing this, and this is still working in progress. We have the models and the draft in the GitHub, and we have our weekly meetings. We have a wiki page that describes the current status. Next slide, please. So this is a summary of the changes we have done since last IETF sessions. I'll go over those items. Next slide, please. So we did a few improvement and the fixes. We checked the names and fixed a few consistent issues. And some attributes types have been fixed, and we for the statistic counters, we now use the counter 64 all over the place. So that's the type we're currently using, and we added the BFD support. That's one comment we received last time. We imported the BFD model and use their grouping. So those are the elements we got from that BFD model highlighted here. And this model is still working in progress, and currently this grouping is available. We are using, but the model still subject to change. So whenever they publish a new version, And if we need, we'll adjust our model accordingly. So which means we still have a dependency on them. So we see how that model will progress. Next slide, please. We revised our model to include the RP state modeling portion. And we, in the model, we added operational status for the static RP. And we also, in the RP list states, we added the mode key into this RP list so that for the same RP root address, we can have two different modes at the same time. For example, SM and BIDR mode for the same root. Next slide, please. So we also revised our RP state modeling portion. So we have this, we now use YAN identity ref instead of enum. So this will give us flexibility for future extensions. And there are some pieces was missing in the previous model, especially for the SM operational state. So we added this part since last revision. And also the SM state operational states modeling also been added at the interface level and for each for the static RP states and for the specific address families. Yeah, we finished the operational states for the BIDR mode. So we included the DF election state and the interface list, which are participating in the DF election. So we also aligned with the newer version of the IETF routing model because this is a model we're based on. We augment this model. However, there are some changes recently, which so require us to do some adjustment. So we changed the model to align with the newer version of that. And this is a base, pretty much like a backbone model. All the protocol models are based on it. And currently, previously they have this routing instance in a hierarchy, and then they are changing to a different ways of doing things. They are moving to the schema mount approach. So after that change, we remove that. The change is not big. However, this is not finalized. Next slide, please. So we have some. I'll talk next slide about this IETF routing things. So yes, this is next step. So there are currently few blocking issues inside the routing area. All the models we are being blocked by two issues. One is the device model structure. The other is the operational states. And the device model structure also will determine how the IETF routing model is structured. And so until those two issues are resolved, so I think all the protocol models cannot proceed too far. And so those two problems has been discussed in the net mode working group. And then they are, this is their highest priority, trying to fix those issues, and so that we can proceed further. So basically, the device model will decide how the structure will, model structure will look like. We have on each device, and how do we implement the virtual router, the logical router, and inside the logical router, you need to have VRF instance. Currently, we call it the network instance. And because different vendors may do that differently, so the structure may not be fixed. It's hard to get agreement. So they're trying to use the schema mount to flexibly changing the structure depending on the implementation. And how to achieve that is still being discussed. And so we'll see. Once that is decided, we will adjust accordingly. Another thing will be the operational states. We currently follow the one paradigm, which is proposed by the open config groups. But this issue is still unresolved. How do we model the operational state is still pending. Once that's decided, we also need to adjust the model accordingly. And also we have dependencies on the other models, like BFD, they are working on that. We want to use the policy, so we'll see how that policy model proceed. And then other than that, we also need to recheck our model, fix whatever we need to fix, and we also like to see the reviews from readers. Previous slides, we also, can you go back to previous slides? So we also trying to figure out better way to model this group addresses, because it's a policy, and we're trying to figure out a better way to do that. We'll see if we can find some way to do this. That's pretty much.
Okay, great. Thanks for all the work on this. I know it's a lot of work with those weekly meetings. So there's been, there's like, I don't know, a handful of vendors that are involved in the design team, and any of you are welcome to join them, join the design team if you like. It would be good to have more vendors taking part, or at least if you're not taking part, it's good if you can look at this model and see if it works with your implementation. So basically in the design team, they have been looking at or comparing implementations from different vendors to find out what is the common things that can be in the model and how to accommodate different implementations. So it might be that your implementation doesn't work with this, or maybe there might be some small changes that would make it better for your implementation. So it's good if you have a look. But yeah, otherwise, I guess, yeah, it will take a while before all those other models are finished.
All right. Okay.
But have you tried to get like review of this? I guess there's like a Yang routing mailing list and people there that can help review models.
Right. So we'll try to. Yeah, we need to get the Yang doctor review, and we probably will put into the routing area Yang coordinating list. Right. We'll do that.
Yeah. Okay.
Okay.
Yeah, thanks. Any other questions or comments? Oh.
Okay.
Okay.
Thank you.
Then we will go on to the IGMP MLD Yang models.
This is Guofeng. I would introduce the progress of IGMP MLD Yang design team. Next slide, please. So 4 parts. First, a brief introduction, then the summary of the progress, and then critical design decisions on that, and the next step things. Next slide, please. You can find the information here. Basically, the mailing list, you can find the archives. In the wiki page, you can find each vendor's information there. And we have, in GitHub, we have our draft version and model files. Next slide, please. And this is a summary of the progress. Actually, the scope covers IGMP and MLD young models and the major protocol extensions for that. And a high-level structure has been done, and the configuration attributes has been done. And operational state attributes has been done. Also, statistics attributes has been done. Still to do is notifications, but I don't think there is too much thing in the notification part, and still need further review. Next slide, please. Here I introduce some critical design decisions by the design team. The first is the module positions. We have 2 options. Option A is place it under routing protocols, just like PIM. Another is under the routing protocol. So finally, we chose option A. For option B, it allows multiple protocol instances per VRF. But since majorly IGMP is an interface-based protocol, so that doesn't make much sense for that. So finally, we chose option A for that. Secondly is we define IGMP and MLD belong to the same module. So it would be easier to make it consistent. You can compare them at the same time. Next slide, please. Third part is even within the same module, but IGMP and MLD share the different, they share the same structures, but defined as separate schema branches. So majorly, this is like the vendors optionally select which to implement. And the second thing is sometimes there is some differences between IGMP and MLD, like address family things, like version numbers, something are different. So we give the extensibility for that. The fourth part is actually we define same features for IGMP and MLD. Here is the example like the global admin enable. They have the same, the IGMP and MLD share the same feature names for that. That means if you want to support the feature in IPv4, you have to support it in IPv6 at the same time. So this make it consistent for the modules. Next slide, please. And here is the structure of the configuration. Basically, we have 3 levels of the configuration schema. First, global level. It defines the attributes for the entire instance of IGMP and MLD. Also, we have an interface global level, which defines the interface attributes for IGMP and MLD. But the actually interface specific level attributes are not existing. It fits for this scenario. The third level is interface specific level. So we define specific interface attributes for that. So the major difference between them is, I give 2 examples. For a global level, if we define 100 for the max groups numbers, it means in total in the entire instance, only at most 100 multicast groups. But if you define 100 in the interface specific level, it means in each specific interface it's at most 100. But in total, it may have 10,000 or much more for that. So that's the difference between global level and interface specific level. And the difference between interface global level and interface specific level is for interface global level is basically interface attributes, but default value for that. So if in the interface specific level, you didn't define the attributes. You will use the interface global values for that. This is what the second example specifies for. Next slide, please. So, and here defines the structure for operational structure. Basically, we have three levels: the global level, interface global level, and the interface specific level. So, which use the same patterns as the configuration attributes for that. Next slide, please. And another thing is for SSM mapping configuration. SSM mapping is basically a mapping star G joins to source G joins. We have two patterns across the vendors. One pattern is you may define the source address and the group range address within one policy. So this is the pattern one. And the pattern two, you can define them separately, which means you can define group range separately and as well as source address. So we need to accommodate both of these patterns. Next slide, please. So we introduce a enum here. So here you have an enum policy. So when this enum is policy, you define them at the same within the same policy. Otherwise, you define them separately. So this is the SSM mapping model. Next slide, please. For RPC, it's just clear groups for IGMP and MLD. Next slide, please. So for next steps, first is notifications, but I don't think there is too much here. Maybe some elected query changes. So in the future, we will discuss this and a request for further review. And since there is not too much in the IGMP and MLD models, and we have a lot of discussions on this, so here is the request: can this draft be adopted as a working group draft? So, any questions?
So how many people have read this draft? Raise your hand if you read it. Okay, only 2 people, I think. Yeah, well, I guess the authors have read the draft at least. But yeah. Well, I mean, so at least the people in the design team, I assume, are in support of adopting the draft. So we have like 5, 6 people that have been working on this. And anyone think that it's too early to adopt this, or? Yeah, given that there's, several people that have been working on this, several vendors, and they are happy with the draft, and there's no feedback here, I think we should consider adoption. We don't have any other drafts, and this is something we need, I guess. Because there's no doubt that we need Yang models for IGMP and MLD. So we'll ask on the mailing list to see what people think about adoption there. But yeah, at least there is fairly good support in the working group, I believe, with the authors and all those different vendors working on this. Okay, let's take it to the list. Thanks. Let's see. So next up is the resilient IGMP or GMP.
Hi, I'm Herman Nanggawijaya, and this is the second time that the draft has been presented, and I'm going to talk about an update to the draft since last I presented it, but probably I'll start with a quick overview, a recap of the draft. So the very first motivations for me to write the draft was when I came across a customer incident report talking about the fact that their multicast surveillance, multicast video surveillance system experience sort of a long delay in receiving multicast traffic. And after some analysis, we discovered that it's actually due to the fact that during some layer 2 network reconvergence time, multicast joins were sent and got lost. And as a result, the multicast joins is only happening when the next general query was sent by the courier. And since then, within the IETF itself, there have been a lot of discussions to do with the fact that multicast on certain less reliable link, like such as Wi-Fi, have been highlighted. And also this week, I came across another use case for making IGMP and MLD to be more resilient. Someone in physics ops suggested that they want to use solicited node multicast group addresses reported by hosts using MLD for mitigating against DDoS flooding attack on neighbor discovery case. And for it to work properly, we need to make sure that MLD is more reliable. So the current solution that is available within the specification of IGMP and MLD, the use of the idea of a robustness variable where hosts send IGMP or MLD membership reports so many times according to the robustness variable specified by the courier. But the question here is that what if all of those retransmission of report messages get lost in the network? Next slide. So this is just a simple graph depicting what the scenario that I was describing later, where membership reports got lost, and there would be what I call a dead period time for the multicast system until the next general query basically being sent by the courier, and the report can be sent again by hosts. Next. So mitigating strategies against the loss of membership reports. Probably we could say that, we could throw in the towels and saying, as we leave it to applications to reset the sockets to make the underlying network subsystem to send the reports again. Or operationally, we can increase the robustness variable or decrease the query interval to make sure that reports are sent more frequently. But those two solutions would make the protocols chatty for all hosts. Next slide. So the proposed solution described in the draft is basically a mechanism whereby the listeners are allowed to send reports beyond the robustness variable specified by the courier until such time either the report is acknowledged by the courier or some other rules to prevent the reports being sent forever. And acknowledgement of reports are sent unicast to listeners. So in the first proposal, the acknowledgement was in the form of reflected membership report messages, but after I proposed that experimentation, revealed that that's probably not such a good idea. So hence the update of the draft. Okay, next slide, please. So this is another graph depicting how the proposed solution works. So basically, when membership reports get lost, the listeners would keep sending reports until report acknowledgement is basically received. Next slide. So an update from the first draft. Basically, the first draft suggested that the acknowledgement could be in the form of reflected report messages, message back to the client. But since then, I find that maybe it's better to actually create new IGMP and MLD messages. So hence, the new message types that I'm introducing in the second version of the draft. Next slide. So, and then since then, I did some more experimentation and came across a slight problem, and the fact that RFC 4541, section 211, says that basically if existing suites that support IGMP snooping receive unrecognized IGMP messages, then it must be flooded. So that means that unicast IGMP report acknowledgement that I'm proposing will be flooded by existing implementation, which conforms to the RFC. So my questions to the room is whether this proposal should update the RFC, and basically the update would say flood unknown multicast IGMP messages as before, but forward report acknowledgement and other unknown unicast IGMP messages.
Just a comment on that. So,
yep.
So at least my thinking is we don't really need to update it, because if this is published and some implementation actually has special treatment of these messages, then it's no longer unknown messages, right?
Okay.
So
right.
it's fine for that implementation to decide according to the specification what to do.
Okay, thanks for that.
That's my thinking.
Yeah, thank you. Okay, next please. So yeah, I've implemented the new proposal in the form of IGMP host implementation on as a Linux stable stream patch, and I also implemented the both courier and host implementation on our own proprietary implementation. I also have patches for both Wiresharks and TCP dumps to decode the new messages, and I'm hoping to publish those open source implementations soon. Yeah, next. So next step, I'm hoping to get MLD implementations for hosts and couriers, as well as packet decoders soon. Maybe I'll try to implement more the mechanism more on more open source stacks, and I'll update the specification to 02, and I'm looking forward to your comments, suggestions, and yeah.
How many people have read this draft? No one. No one read it. Based on the presentation, do you think this can be a useful mechanism? Do you think adding acknowledgements to IGPMLD is a good idea? Any thoughts on that? So, okay, no one has any thought on that.
So my question,
yeah.
by the way, would this fulfill the charter item that says?
Yeah, I was just gonna mention that. So you know, you saw in the earlier presentation too that there are issues with multicast on Wi-Fi in particular, and we have a charter item to come up with improvements to IGPMLD to work better on Wi-Fi links in particular. So this could be one of those potential improvements. But none of you have any thoughts on whether this is going in the right direction, whether we should try to do something like this. I'm not saying we should adopt this particular document necessarily, but is this the right kind of thing to try to achieve? Okay, no comments. Okay, so please read the document if you find this interesting, and also think about whether there are this or if there are other things that we should do to IGPMLD to work on Wi-Fi, etc. Okay, so let's try to get some discussion on the mailing lists. I'll try to help. I'll try to help push people to read it. Yeah. Okay. Okay. Yeah. Thanks. All right. Next presentation is on Spring or Spring Multicast. Let's see. Yeah.
Okay.
Just a second here.
No problem. All right, great. So the box on the floor tells me I'm in the zone here. Okay, so this draft is a framework for computed multicast applied to MPLS segment routing, co-authored with Jeff Tansura. Next slide, please. So what is this draft about? What it discusses is a technique for constructing multicast trees where the actual state installation has been simplified down to only those nodes that explicitly have a role in multicast, which means either they're sourcing traffic, they're syncing traffic, or they're replicating traffic. And we take advantage of the a priori set of unicast tunnels to interconnect those points. So what the draft does is it goes into this in comparatively exhaustive detail. There's some terminology we needed to sort out. It describes the overall approach. It discusses how you can construct either completely loose or specified multicast distribution trees pretty much to any level of granularity. It defines the algorithms that are used to do this, and it goes into the FIB installation procedures that are associated with it. Next chart, please. Now, to do this, each node needs is a comprehensive knowledge of all of the nodes that are participating in the multicast tree and the topology. So to make sure all the nodes have that information, what we do is we augment the routing protocol with some TLVs to advertise multicast membership. Now, there's exemplars of this that have existed in the past, MOSPF, RFC, something or other, 1500 or so from just before I started coming here. More recently, RFC 6329, which was extensions to ISIS for shortest path bridging. Now the question is why would we want to do this? Well, there's a bunch of benefits you get out of this. The first off is on a topology change, there's an absolute minimum number of messages to converge the network, because only the topology change needs to be advertised, because all of the nodes have the rest of the information they need to converge multicast in the IGP. The fact that we're constructing it using tunnels significantly reduces state. And this is a fairly big one, because at least my experience with shortest path bridging was that multicast state could start to dominate the network when you were using large amounts of multicast because you were doing VLANs. But to give an example of this, if I've got a node, if I've got a multicast tree with a root and 5 leaves, then the absolute worst case is that 10 nodes would need to install state in the network above and beyond the unicast state they were already going to install. And that would be true irrespective of the network size. So the amount of state that needs to be installed is dramatically reduced. We get this serendipitous byproduct that we reduce the bandwidth that is required because we're actually computing either minimum cost or near minimum cost trees. And compared to just sort of randomly generated shortest path multicast trees, that could work out to about 30% or so. We're going to see unicast recovery for most failures. If the primary unit of construction of a multicast tree is a unicast tunnel, then LFAs, FRR, all of these things kick in to actually restore service a whole lot faster than multicast itself could converge. We're reusing the existing MPLS data plane. That to me is a fairly big one because that's simple, it exists, it's operationalized in merchant silicon. Now the draft talks about MPLS. As far as Spring is concerned, it wouldn't take an Einstein to figure out you could do this with an LDP network as well, because it also has the same thing, label stacks and a full mesh of tunnels. We also believe this could be applied to IPv6 for segment routing, but we've not spent the cycles to fully bottom that out to be absolutely sure that how IPv6 is being modified for segment routing would also support this technique. And the other serendipitous aspect of this is because we are using tunnels, as far as the computation of the multicast trees is concerned, most nodes can determine fairly early in determining any individual tree whether they're going to need to participate in it or not, and can kick out and move on. So we can start reducing the actual computation requirements in proportion to how much we're reducing the amount of state that we need to install. Next chart, please. So one of the aspects of tree generation is because we're using unicast tunnels and we're going to be using ECMP, if we just picked any old multicast or any arrangement of replication nodes willy-nilly, we could see multiple tunnels being used on a single interface for a packet. Now, the ideal solution to this is we produce absolutely minimum cost trees, and this requires a fair bit of sophistication in the algorithm, because what it also means is we need to produce a unique solution per S, G tree when we're doing the computation. This starts to look a little bit onerous. Next chart. And what we're actually doing is a tree pruning algorithm. It is described in the draft, and what we start out is we compute from any given route the fully inclusive shortest path tree. That includes all multipath variations. And then we apply a series of pruning operations to it. Now, there's two classes of pruning operations we do. The first is fairly obvious things, proceeding to eliminate all the transit nodes that aren't doing anything, proceeding to eliminate the nodes that are not on the shortest path at all between the route and any leaves, et cetera, et cetera. And that will actually resolve about 97% of the leaves. And what I mean when I say resolve is that after I factor out multipath, they will have a unique shortest path to the root. Now, if I've not fully resolved all the leaves in the tree at this point, then I have to do a pruning operation that I would describe as kind of a best guess. And once I do a best guess, I then need to audit those leaves that I needed to guess on, because I haven't necessarily produced a shortest path tree. Probably about 3% of those will need to be corrected. But what it means is most of the time we're sort of ripping through this fairly fast once you accept the computational load of doing the pruning in the first place. And like I said, because with the best guess is actually pretty good, there's only a tiny number of trees we would need to, shall we say, adjust. Next chart, please. Now, it is computationally intensive, and in particular because I'm having to compute each individual tree. But like I said, we pick up a whole lot because of the fact that we're using tunnels. A lot of nodes can exit out of and computing any individual tree early. And even as they proceed to prune, they can also kick out in progressive increments as they go through it. And there's a whole lot of other shortcuts you can take. I'm going to go into that, a little bit of that in a second. The other aspect of this is because we've reduced the amount of information that needs to be synchronized in the fibs because we're using tunnels, that is yet another economy or saving there. Certainly in the past, my experience was synchronizing the control plane and the line cards was a significant portion of the convergence budget. And the fact that we're substantially reducing the amount of state that needs to be synchronized for multicast helps that along. Next chart, please. So we actually prototyped the algorithm that are described in the draft, and we did this for a couple of reasons. One was to verify correctness, and the other was just to see if this thing actually was going to be computationally tractable. And so complete truth in advertising here, this was done on a 1.8 gig i5 CPU. It's sitting over there in front of Lucy on the chair. And our product folks told us that, well, you know, if you can't generate some numbers for a 1,000 node network, nobody's going to pay any attention to you. So on a single threaded Windows i5, we were able to resolve about 1.2 million endpoints per second in a 1,000 node network. So those numbers weren't too shabby. And of course, those numbers are only going to get better with Moore's law, which is where we start going, you know, hey, this is actually within striking distance of being both tractable and deployable. And so that to me is actually pretty cool. Next chart, please. Now, so far I've discussed just the concept of a completely loose multicast segment where I specified the root and the leaves and computation and the IGP filled in the rest. If I want to do more explicit routing, then all I simply do is flood in the IGP how I want to cross-connect these computed segments together. And I can do this pretty much to any level of granularity. So whether either a single hop or have partially loose hops, partially strict hops, it's actually pretty straightforward to do this. Now, I know in the past when I've seen approaches to this, one of the things that concern me is that I can ensure a completely strict tree is loop-free and will not crop and be planar, and I can ensure a completely loose tree is planar, but I was concerned about a hybrid tree. Well, it turns out that if we assign each computed segment its own multicast SID, then regardless of the state of the topology, I can actually guarantee that even if it's not a planar tree, it will not conflict, it will not loop, and it will not produce duplicates, because the assignment of a unique SID to each computed segment makes sure that even if they cross over, we don't get corruption of the forwarding behavior that we want. Next chart, please. So we have this framework draft. I really welcome people to read it and look forward to getting feedback, because so far it's been a whole lot of fun working on this and you know, really enjoying sharing it. We're going to bring forward in some future drafts the required IGP extensions, interworking with existing mechanisms. We're going to pursue standards track. I know there's some discussion between the leadership as to if that was going to happen, where it would happen, whether it would be here, whether it would be spring or whatever. But that's kind of where we're at right now. This is the first time, of course, this has been brought forward, other than I presented it in spring yesterday. And so at this point, I'd love to welcome questions.
This is Dino, just one quick question. It wasn't clear to me if you're building FPF trees or RPF trees.
Effectively the equivalent of RPF trees. Okay, you're probably...
No, you're doing an optimal forwarding tree, right? Minimum replication tree.
Okay, so I have to apologize for my ignorance. I'm coming at this from.
So since the IGP is participating in removing paths, that's why I'm asking.
So I think he's asking the definition. So an RPF tree is as the receiver's view towards the source. The join mechanisms build that tree. An SPF tree is basically from the source's view, taking the shortest path, replication path down to the receivers. From what I understand, he's doing an optimal forwarding tree, which is minimum replication points. I want to follow a single path until I absolutely have to replicate to minimize the number of replication points I have in my distribution tree.
Yeah, that would be an accurate, that's an almost accurate characterization. Like I said, with the pruning rules, if the first class of rules is successful, then I have achieved that. If it's not, then I'm sort of merely close and I'm simply auditing for ECMP friendliness. So I hope that.
But the replication points or the fork points of the nodes in the middle of the network is based on where the state is being put, right?
Yes.
Right.
So is it closer, if it's closer to the receiver, then it's receiver initiated, right? And so it's an RPF.
No, it's still a topological view. It's not initiated either way. It's controlled or calculated.
Yeah.
And then pushing the state down in. So you're not taking state out of the tree.
I understand how it's doing it. I'm understanding why. I want to understand why it's making this decision that it is.
He's trying to minimize the number of nodes that have replication state.
Understand that too.
Can I help you with your question?
I'm around.
I'll take it offline.
Achieve? That's the question I have.
I'm around if you want to follow up with me. So.
Lucy Yang. Yeah, I think this some new idea good, and also this kind of the IGP-based extension to support a multicast. It's we've been proposed, before for these things. So I would like to see, where we're taking these things. Definitely, the IGP can do these things, and we should have a natural way to do the multicast instead of a, fully unicast way to support a multicast. So I really like to. And also, I want to inform. Yeah, here requires some IGP extension. I think several years ago we already have some, the proposed this kind of extension for the membership. The solution.
Well, the thing is, we have exemplars of doing it in the IGP, but of course, we're going to need one.
If this one tailored for the MPS, we will. But I just want to generally see, where we're taking, these things, because this one for MPS, IGP can do that, therefore.
Yeah, I was going to mention that too, and so there's several drafts talking about IGP, not IGMP, IGP extensions to signal like receiver state. I think also in the beer working group, there's some drafts talking about signaling like receivers in the IGP. So it would be good if you could have like, generic IGP extensions that could work kind of separate the exact routing scheme or how we build the trees. So.
Yeah, and the other aspect is I think in the draft it also mentions trying to tie it into the BGP discovery mechanisms for MVPNs, et cetera, which is also going to be required to make this part of a larger solution.
Yeah. So we need to discuss a bit, I think, with chairs and ADs and so on to find out where to take this. So it could be maybe done here or spring. And then there's like this IGP extensions and this other draft that has been around for a while, presented here in the int area for multicast IGP. So we need to find out where this belongs or where we should do the work. So how many people have read this draft or think this is interesting?
There's two different questions.
Yeah.
Who's read the draft?
Okay, who has read the draft? Okay, there's maybe 5 people.
Yeah.
How many people think this is interesting work? Okay.
Yeah, I guess the question becomes how many will read the draft after hearing that?
Yeah. Do you have any thoughts on where this work belongs? Is it a good idea to do it in PIM because we're talking about building trees and so on? Or is it like more segmented routing and maybe better to do in spring?
Kind of uses a little of everything, right?
Yeah.
Yeah.
At least I would say there are people here that have some knowledge about building multicast trees, so it's good if PIM can be at least involved in some way.
Yeah. Yeah, that's certainly the concern of the Springs chair. The Spring chairs was that they did not have the multicast expertise, but they understood Spring, which is one of the reasons I'm standing here in front of you.
All right, I'm not chair, so I'm running up, right? This is Greg. We already had a conversation in the Spring group, and I wanted the conversation to take place there because there weren't multicast people in the room, right? So that's the gap we often see, and if not always see in the IETF. It's people will say, okay, but that's out of scope. And unless the multicast experts are there, it just dies. So, you know, my issues with this, I'm trying to understand what we're trying to accomplish. It's a lot of complexity. We're trying to go to a direction where we're removing all of the state. But I do appreciate at least the motivation of trying to minimize that state. But if this work's going to be adopted, I would like to see it adopted here, where we actually have multicast experts, and it would actually get some engagement rather than just dying somewhere where people don't care about multicast.
Right, because at the moment, you're familiar with what the draft describes, but reality is the whole gamut of how multicast has been done obviously can be derived computationally. Right. So, I mean, I'm sure there's lots of other things people are going to think of to do with this. So are there any other questions or comments? Then I would encourage you to read the draft, and I look forward to discussing it with folks on the list. Thank you.
Yeah, thanks. Yeah, please read the draft, and we need more activity on the mailing list. So that would be great. Okay, thanks. We got one last presentation on MLD security.
Hi, my name is Anarai. I'm one of the 3 authors of Draft Wing PIM MLD Security. The background of this draft is that I work in an organization where a lot of security research is performed, and at the same time we are involved in quite some IPv6 activities. So 2 years ago we sat down and we're asking, like, okay, let's have a look at MLD from a security perspective. So we built a lab with a number of operating systems, with some devices, and we figured out like what could go wrong and how maybe MLD might be attacked or misused from a security perspective. And the draft is a kind of result of these activities next to a very detailed technical report, which is available on the web. Next slide, please. I'm briefly covering three angles. That is, first, I'll provide kind of high-level problem statement from our perspective, from a security research perspective when looking at MLD. Then I'll discuss the specific properties and the attacks we looked at, and of course the mitigating controls that we suggest as from the draft. Next slide, please. From a security research perspective, the first thing when you look at, say, a protocol or a number of protocols, by the way, I will not differentiate between MLD v1 as of 2710 and MLD v2 as of 3810 during this presentation. If needed, I will comment on this, but for the moment, I use the term MLD for both variants. And the first thing we did was, okay, what does actually MLD serve for? I don't probably have to tell anybody in the room what it serves for. The thing is, when we looked at it, we spotted there is this, what we think from a normative
it's not working.
No idea. I will soften my voice. We think there is a kind of unfortunate ambiguous statement in 4861, which essentially says joining the solicited node multicast group is done by MLD, and this is done what does this tell us? Is that like a prescriptive, a normative statement has to be done? Or does it like describe operational or implementation reality? A point is, we think as a consequence of this statement, we can observe that pretty much all operating systems we looked at actually had MLD enabled by default, except for OpenBSD. And pretty much the first packets, the stacks or the interfaces sent out after initialization were MLD packets. So let's state for the moment that MLD is like ubiquitous. At the same time, there is a number of vulnerabilities, so properties which make it susceptible to attacks, and there is a number of actual attacks that can be performed. Next slide, please. The main vulnerabilities, so properties which actually facilitate things going wrong, is first it's easy to downgrade to MLD v1, even in environments where apparently only v2 is going to be used. Secondly, there is RFC 3810 says it's for debugging purposes, it's allowed to send MLD packets to unicast addresses, which at a first glance doesn't seem to be an issue, as we will see in a second. It turns out to be, from a security perspective, highly problematic, as we think. And third, there is the active carrier on a given local link. That one is elected by the lowest link local IPv6 address, and this election can easily be won from a say malicious party. As a consequence, there are several types of attacks which are actually possible. The first one that is easy, one can easily enumerate which hosts are on a given link, even passively, just by listening to MLD and to identify the operating system, as different operating systems join different multicast groups. This in itself isn't too much of a security problem, we think. More, say, an issue is that with MLD, it's very easy to perform amplification attacks. Just a simple example, if you send out a forged query on a link where, let's say 200 nodes are active, those 200 nodes will respond, each of them, depending on the version now, but let's say it's MLD v2, for each multicast group, in average, that's 4 default state of most operating systems. So for 4 groups, 2 reports are sent, multiply this by 200 nodes. This gives, like in this example, 1,600 reports as a response to just one forged query. That is a high amplification vector, which could easily fill the local link. And we did some testing, just sending reports with multiple MR records to devices. And we were able to render unresponsive the devices involved, including high-end devices like Cisco ASR boxes, by just sending packets from one single source. This is obviously, as we think, is a problem. And the third type of attacks we performed were actually disrupting multicast distribution or multicast the transmission on the local link, by taking over the carrier role, then sending done or empty report messages, and say faking the last listener query. So actually the former and the legitimate forwarding former queries stopped forwarding the traffic. And this would be another, what we think, problematic. Highly, that is a very relevant attack vector. This brings me to the last part, which is the next slide, please. The controls that we suggest as from the draft. The first one, and I personally think that's the most important one, would be to implement an RA guard, similar feature that we call right now MLD guard. which is a stateless filter on the switch level, switchboard level, which essentially blocks ICMPv6 type 130 messages. There is no need why a host should ever send out we can identify too much needs. Let's state this more cautiously. We don't see a need for hosts to send out MLD queries. So just drop them on the infrastructure level. The second part of say suggestions we came up would address properties of MLD as it is, which is we suggest a different handling of the hop limit. Instead of checking if a given packet has a hop limit of 1, and we did analyze several operating systems, a number, say about half of them actually accepted packets with hop limit bigger than 1, which they shouldn't as of the spec. So a different handling of the hop limit, check for 255 and send with 255. It might be an idea not to allow downgrading anymore. So there is some stuff we laid out in the draft, but those suggestions actually would mean working on a newer version of the relevant specs. So that's it from my side. The main question here is, do you think this is reasonable work? Should we expand on this further? So far the draft exists in a 0.1 and a quite early version, which has most of what I just discussed in it, but we consider expanding this as we think namely from an operations perspective, MLD with more widespread deployment of V6, obviously, these problems won't go away. Actually, they will get bigger. So, any feedback on this walk? Is this useful from your perspective? Do you think this should be enhanced, expanded? Do you think PIM is the right place to do this?
So, yeah, this is Stig, and as a working with participants, I think this is quite useful work. It's quite interesting, and I think it applies also to IGMP to a large extent. I think there's two things to consider. One is, operational issues. Are there things you can do to secure this from a administrative point of view? Are there recommendations to implementers for how to implement things, or implementation mistakes? The other thing is if there's if we should revise IGMP and MLD protocol specs to become more secure. And there's a lot we can do there. A few comments otherwise. So one about the downgrading. I'm kind of wondering today if there's actually any MLD version 1 implementations out there. I know there were a few before, like Windows 98, for instance, but they are not actually deployed anymore. So that could be something to think about. When it comes to the hop limit, the spec says that you should use a link local source address, and routers are not supposed to forward those packets, so that hopefully helps. I agree 255 would have been a good thing to specify, but it's also difficult how to actually migrate or transition to that, because it would take many years for hosts to actually be updated. So
yeah, I agree with that.
Yeah, I could spend half an hour discussing this, but we have to stop soon. Any other people have any questions or comments on this? Do you think this is useful work? Looks like people are almost asleep back here. At least one person thinks it's useful. Yeah, I think it's useful too. But yeah, it's definitely within our charter, I would say, to work on IGMP and MLE protocols and to make sure they are secure. That's important to us. So at least I feel like this is something we need to work on. So please read the draft and comment on the mailing list. I'm fairly sure people think this is useful, even though they are asleep back here.
Yeah, having the last slot before lunch is not the most like exciting.
But yeah, I would say there's some concerns about, you know, how can we change the spec and be backwards compatible or other things. Maybe there are like small things we can do to make things secure without breaking that. Yeah, there's lots of things that could be considered. And yeah, you mentioned also like MLD guard, so maybe you may not need necessarily to specify exactly how to implement it, but it's at least there could be a recommendation that this is something that would be useful to have.
Yeah, from a personal perspective, given I have a background in large-scale enterprise operations, I would think MLD guard would be the most. If there was like the ferry turning up, you have one wish for securing MLD. MLD guard would be my response.
But okay, let's thanks. Let's you know, take it to the list. I hope to see some comments there. Okay, thank you.
Thank you.
Blue sheets. Everyone signed blue sheets? Where are they currently?
But yeah, thanks everyone. That's the end of the meeting. But yeah, please try to read the drafts and give comments on the mailing list. We need more activity. Thanks.
Hi. Well, last weekend was meeting, and there are gigs. So I always knew the IETF by name, but not
Right, yes.
I'm kind of a tourist here.
Yeah, that's great.
Yeah, and they told me, no, you should just write an email, we'll give you like a free pass for a day. And I just asked my boss, I want to see this, and let me go. Okay. That was, this is a robot. I mean, you guys are actually finding nice offices.
Yeah.
I mean, what, how many, more? My question actually would be, how do you guys do this?
Yeah. So there was, there was like an introduction to new people on Sundays, but you missed that, I guess.
No.
Are there, is that recorded?
Yes. So if you go to IETF, to the IETF,